Alright, ladies and gents, this video for our chapter on quadratics is based on complex numbers. Up until now, we've been told that we can't take the square roots of negative numbers. So if I gave you a problem, say square root of -4, we would say that's impossible. You can't take the square root of a negative number. Well, in this section, we're going to explain how you can take the square root of a negative number. And we're going to do that by introducing a new number to our arsenal. We're going to introduce the number I. I is equal to the square root of -1. This is going to help us evaluate square roots similar to this guy up here. Okay, so let's take the square root up here. We have the square root of -4. I want to simplify that as much as I can. Well, we can break that up into two different numbers. Square root of 4 times -1. We all know the square root of 4 is 2. And we know the square root of -1 is just got introduced to us, which is I. So now instead of saying square root of -4 is no solution, now we can say square root of -4 is 2I. Alright, here we have 4 problems where I want to simplify as far as we can. So let's take it step by step. We have the square root of -9. We can break that up into squares that we know. We know what the square root of 9 is. And we know what the square root of -1 is. The square root of 9 is 3. The square root of -1 is I. So it's easy as that. Just taking it step by step. Let's try the negative square root of 25, or square root of -25, I should say. We know what the square root of 25 is, and we know what the square root of -1 is. Square root of 25 is 5. Square root of -1 is I. Now, we're looking at square root of -18. This is going to be a little different because 18 is not a perfect square. So we're going to have to break it up a little bit more. So first, let's just break up the 18 and the -1. Now we want to try and break up 18 so we see perfect squares. Well, we know 18 is the same thing as 9 times 2, 9 being a perfect square. So we know the square root of 9, which is 3. We know the square root of -1, which is I. And we don't know what the square root of 2 is. So that's going to stay inside the square root symbol. And last but not least, we got square root of -6. Trying to think of numbers that can be divisible into 6. We don't have any perfect squares. We got 3 and 2, but those aren't perfect squares. So we're just going to leave it as square root of -1, which is I, times the square root of 6. And that's your final answer. Okay, here we have another simplifying problem. Here you're given a imaginary or complex expression, and they want you to simplify as much as you can. So let's look at the first one here. We got 2I plus 3I. Well, that one was just a simple combine like terms. Well, we have an I in both terms, so 2I plus 3I is 5I. That's as far as you go. Next one we have 3I times 4I. So 3 times 4 is 12. I times I is I squared. Now you might want to stop there, but we know that I squared can be simplified. Since I is the square root of -1, we know that I squared is just going to be -1. So our answer is -12 here. So let's take a look at the next one. We have a binomial being multiplied to each other. So we're going to do the FOIL method. So 4 times 5, which is 20. And then 4 times -I, -4I. I times 5, which is a positive 5I. And then I times -I, negative I squared. Let's combine like terms as much as we can. And remember, back over here, we saw that I squared is equal to -1. So we have 20 plus I minus -1. That simplifies to 20 plus I plus 1, which is 21 plus I. And this is as far as we can go to simplify. Now you saw on the last slide that I squared was equal to -1. Well, the funny thing is, if you raise I to an exponent and you do it enough times, you see the numbers start to recycle. So we know that I is equal to the square root of -1. We know that I squared is equal to -1 from the last slide. So let's see what I cubed is going to be. I cubed is the same thing as saying I squared times I, which in this case is -1 times I, which equals -I. Let's see what I to the fourth would give us. I to the fourth is the same thing as saying I squared times I squared, which is -1 times -1, which is equal to +1. So the next step after I to the fourth would be I to the fifth, which is the same thing as I squared times I squared times I. -1 times -1 is 1, so we just got I. So I to the fifth is the same thing as I to the first, which is our I. And I to the sixth is equal to I squared times I squared times I squared. And that turns out to be -1, which is I squared. So after you get to the fourth one, they just start repeating each other over and over and over again. So if I wanted to do a problem like I to the 47th or so, I want to say, what is I to the 47th? Well, knowing that after the fourth power they start to recycle, I can see how many times the fourth power goes into 47. So I'm going to do 47 divided by 4. That comes out to it comes out to 4 times. 11 times. I to the fourth 11 times with the remainder of 3. I to the fourth was equal to 1. So it's going to be 1 times I to the third, which equals -I. So I to the 47th is the same thing as -I. Let's try the same thing with something a little smaller, a little easier to deal with. I to the 17th. Okay, how many times does 4 go into 17? 4 goes into 17 4 times, with the remainder of 1. So I to the fourth was equal to 1. So I to the fourth was equal to 1. So 1 to the fourth power is 1. 1 times 1 times 1 times 1 is 1. So we're left with I to the first, which is just plain old I. So I to the 17th is the same thing as I. So we're going to use that to help us simplify these problems. Alright, after watching that video, you should feel comfortable in giving these problems a try. I want you to do numbers 18 to 21, 24 to 27, and 30 to 31. These can be found on page 598 of the textbook. So give these a try. Come to class with questions.